Good afternoon, everybody. It's Mrs. Frame. We're just going to do the first page of your review today. You can do the factoring tomorrow. All right, here we go. I suggest you please take out your notebook and you try these as we go. Try to answer them before I explain it and then watch to see if you're doing things right. All right, number 1. You are given a following set of real numbers and you're asked to list their subsets. So things you have to remember, look up what irrational means. Okay? Irrational. Those are the numbers like pi. They're the ones that never, there's decimals that never terminate and never end. Like for example, pi, it's 3.14 dot 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 forever. That little dot indicates that it's irrational. It goes forever. Things like the square root of 7. This is also, if you plug it into a calculator, one of those ones that'll give you 2.67 dot 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 forever and ever. Okay, these are the irrational numbers. They're the ones that when you plug them into a calculator, you get a decimal that never ends. Right? So if you're looking at your categories up here, you have, this is not a decimal, not a decimal, not a decimal. This is a non-perfect square root. I can't solve it without a calculator. It's irrational. Pi, as I just mentioned. And here we have 6.12 dot dot dot. There you have an irrational number because that is telling you that goes on forever. Integers, look it up. Make sure you know what they are. Alright, as you look at your list, the integers are your whole numbers, positive and negative. So you start here at -3, it's a whole number, it's just negative. 2/3 is not a whole number. 0 is. This is not. It's one of those weird decimals, not. 4 is a whole number. Excuse me a moment. Sorry about that. 6.12 dot dot dot. Your ellipse forever. 7 is a whole number. 7.9 is not a whole number. It's got a part on it. So there is the end of that. Your last numbers are your rational numbers. They are the opposite of irrational. So that means that anything you did not put in this group of irrational, you will put in this group. It's any number that you can write as a ratio. So any of these numbers you can write as a fraction. -3 you could put a 1 under it. It's a ratio. Anything that is not irrational is rational. And there you go. Next assignment. You were asked to solve for the variable. I would really like for you guys, if you really struggle with this, to draw a line down your equal sign. We call this the barrier. Anytime numbers cross the barrier, you use the opposite operation, but first you have to simplify each side. So first we're going to distribute 2x minus 8 minus 2 equals 5 minus x. Now you're going to combine like terms on the left side of the equation. I'm looking at 2x minus 8 minus 2. I can put these numbers together, and I'm going to. That's minus 10 equals 5 minus x. Alright, now I can't do anything on the left side anymore, and I can't do anything on the right. So I'm going to go ahead and move my x to this side. Now as I'm coming across the barrier, I've got to do the opposite sign. So it says minus, so I'm going to add to bring it across the barrier, and add x. Okay? Cancel those out because it's 0 now. I have 3x minus 10 equals 5. And then we are going to move now, take the 10 across the barrier, plus 10 plus 10. That cancels that out, leaves us with 3x equals 15. Divide by 3, divide by 3. Because again, we're going across the barrier, we do the opposite of multiplication, division. X equals 5. So there's your answer for that one. Alright, this one here, you just find your least common denominator, and it is 12. So all you got to do is make them all have 12s in the denominator, and then you can cross the denominators out. So we would multiply this times 6 times 6 times times 3 times 3, and this is times nothing. So we get 6x over 12 minus 9 over 12 equals, you can go ahead and distribute here, 2x plus 2 over 12. And then guys, you can just eliminate your denominators. 6x minus 9 equals 2x plus 2. Draw your barrier. We're going to bring the x's. We can't do anything on this side or this side, so we're going to bring the x's over this way. It says plus 2x, so we're going to subtract 2x. Minus 2x. Cancel it on that side. Okay, that gives us 4x minus 9 equals positive 2. Now we're going to move the 9 over. So we're going to add 9, opposite operation. Got to add it to the other side. Cancels it out on this side, giving you 4x equals 11. Okay, we're still taking numbers across the barrier. The opposite of multiplication is division. X equals 11 fourths. Alright, this last one is an inequality, but it is the same idea. You've got a barrier. So first distribute. Negative 3x minus 27 plus 6, because you're just giving the negative 3x to the things in your group, is less than 1. Okay, now we're looking on the left side to see if we can put things together, and we can. We can put those together. We get negative 3x minus 21 is less than 1. Move the 21 to the other side, so we're going to add it over the barrier. Here we go. We get negative 3x is less than 22. We're going across the barrier. One thing to remember, when you divide with an inequality, you always have to remember to reverse your symbol. So x is greater than, positive divided by negative is negative 22 thirds. And that one is done as well. Okay, there we go. Next thing. Alright, here we go. You need to pull up your interval notation in your graphing notes, so look that up in your table of contents. We're going to be graphing a compound inequality here. So we're trying to find the numbers, the x's, are just the unknown numbers that are between 3 and 8. So you can just put your 3 and 8 on here, and then you just have to remember, when you have a greater than, the equal to sign, that's a less than or equal to sign. Okay, the x is between them, less than or equal to. X is 3 is less than x. When it has the equal to sign, you have to use a bracket. Okay, it has to be a hard lines bracket with that equal to sign. On your 8, x is less than 8, so we're talking about all of this stuff right here, and it's less than 8. You have to use a parentheses here because it does not have an equal sign. So we're looking for all of the numbers that fit here. That's all of these numbers here that stand for x. Okay? Now this one here says write it in interval notation. Well guys, interval notation looks a lot like a graph, so I'm going to graph it first. And let's remember how it says. It says the set of all x such that x is greater than or equal to 10, right? So we're looking for a huge set of numbers that are greater than 10. Let's graph it first, and then it's easier to see. Greater than or equal to 10, okay? Greater than, it's pointing this direction. So we're looking at all the numbers to the right of 10, and we have to use a bracket again because of the equal sign. Interval notation looks just like the graph. It starts at 10, and your line, all your x's go forever to infinity, and infinities always get parentheses on them. Okay, forever and ever. So this is your interval notation right here. Alright, very last thing we're going to do today, simplifying expressions using your rules for exponents, and I really suggest you put these rules on your note card so you don't forget. Alright, this first one, this is the multiplication rule. You can regroup them if you wish. And remember, when you're multiplying the same base, you add their exponents. So we would go with the exponent. This is an exponent of 1. That C's also got a 1. So we're going to do a to the 3 plus 1 because you add, b to the 2 plus 3, and c to the 1 plus 2. And then you just simplify. Got it? And that's the product rule. This here, guys, is the division rule. Okay, so what we're going to do is we're just going to go ahead and follow the division rule. For those of you that remember that I say take the little to the big, go ahead and do that. What we're going to do is we're just going to take them up and subtract. So we're going to take this 6 up, we're going to subtract it, cancel it out. We're also going to do the same thing, subtract -5, okay? And we're going to get rid of that. So we're going to do this math here. We have -5 minus 6, and that's -11. And then here we have a double negative, which makes a positive. -3 plus 5 is +2. Now, the only thing is you cannot have any negative exponents. So your negative's got to drop down to the denominator. So your final answer is there. Okay? Here you have power of an exponent rule. You have things inside. You can't do anything here because they don't have the same base, so we're going to distribute your exponent to these powers here. You get r to the -12th and s to the -8. Because remember, when you do power to another power and you're distributing, you always multiply when you distribute. Okay, these are negative, so to make them positive, you just have to flip them over. Okay? And there you go, guys. That's all I have for today. I hope you study and you get your note card filled out with all kinds of good tips and you do well on the next test. I will make another video tomorrow. Have a great day.